Hello, Calculus, and welcome to 6.4. I hope you enjoyed 6.2 with the story problems, and you took time to think and try to figure them out before you went to the answers. They're a lot of fun, and they're good for you. We do not have to do 6.3. It's not part of the curriculum, so we're skipping to 6.4. What's this? Implicit differentiation. What that means is you're given an equation, and then you're asked to derive it with respect to a variable that is not part of the equation. So I want to know distance with respect to time, but the time isn't in the equation, something on that order. So let's go. Make sure you got your calculator ready, and let's have some fun. All right, so when we do implicit differentiation, first we're going to start off with no story problems. So an explicit function means you can write it in the form y equals, so I can solve for y pretty easily. Okay, an implicit function means I cannot do that. Like if we look here, solving for y is next to impossible. So we have to do what we call implicit differentiation. So remember, no story problems yet. So I want to find the derivative of 3xy plus 4y squared equals 10. Now, the derivative, you do this separately. So we're going to break this down into 3x and this into y. We could have put the 3 with a y, it wouldn't have mattered. We do the terms and we do the derivative of each. So the derivative of 3x is 3 with respect to x. Now the derivative of y with respect to x is just 1, but we have to put dy dx with it, the derivative of y with respect to x, to tell them which variable we used. So we do the derivative of y as if it was by itself. So this is y to the first, correct? So we do the 1 down in front, subtract the 1, which goes away, which just gives me dy dx of y. That's just this term. That's the only one we've done so far. Now we're going to do, so the derivative of that entire term, we have to put that together. So we're going to use our 3x, so now you're using your chain rule, or your product rule. The derivative of, or the first times the derivative of the second, plus the second times the derivative of the first. And we put that together. And that gives us 3xy. So product rule and basically the chain rule up above, or the quotient rule above. No, again I said that wrong. Your exponent rule. Okay, now we want to do 4y squared. I probably wouldn't do this one this way because the derivative of 4 is just itself. I am sure you're going to look at, whoops, hang on, sorry about that, my screen jumped. I would probably not do this, and I don't think you would either. We're not going to break this up. We're going to do 4y squared. And I want to find the derivative of this with respect to x. So first you just do your derivative, which gives you 8y. But remember, since it's with respect to x, and it's the y variable, we have to do dy dx. So then the derivative of 4y squared is 8y dy dx. So that's the derivative of the second term. Not as complicated because there was only one variable. So now we put this all together. We had the derivative of the first. Remember, we had to use our product rule. And plus the derivative of the second, set equal to 0. Because the derivative of 10 is 0. The derivative number is always 0. Now we have to solve for dy dx. This is the goal. We have to get it apart. So to do this, this guy doesn't have a dy dx. We just subtract him to the other side. We have the minus 3y. We're going to factor out the dy dx, and that's all we're going to factor out because that is what we're solving with. Even if there was something else in common, nobody wants him. Factor him out. Then we have 3x plus 8y. We divide by him. And your final answer is negative 3y over 3x plus 8y. That's the derivative of y with respect to x. All right, pause and try yours. Okay, you have 3 terms this time, so we have to be a little careful. The first one isn't so bad. The derivative of x squared, we already know that. That's 2x, nothing fancy. Okay, the derivative of our y squared would be 2y, but since we have to do that with respect to x, correct? All right, equals. Now this last one is a little bit trickier. So we have to do this. So let's go over here. So we know the derivative of x equals 1. right? And then the derivative of y is equal to dy dx. So these are my derivatives. Now we have to use our chain rule. So it's the derivative of the first, 1, times the second, plus the derivative of the second, which is dy dx, times the first. All right. Now that we have that done, we have to solve for dy dx. So when we do this, I'm going to move the y over. And then I'm going to move the 2y dx over. And we're going to write this in correct order. So this is going to give us, we have 2x minus y, this guy cancels, equals x dy dx minus 2y dy dx. All right, I hope you've done well so far. Now we're going to factor out the dy dx. So we're taking out dy dx, my derivative that I'm solving for, and get x minus 2y. Now all we have to do is divide by x minus 2y. So we have 2x minus y over x minus 2y equals the derivative of y with respect to x. I hope you did well. I think those are a lot of fun. All right, a little bit more complicated. So let's go through this one step by step. Okay, first term is the derivative of x, which is just 1. Second term, now we've got 2 parts again, so remember we're going to have to use our chain rule. So the derivative of x to the 1/2 power, we write these as 1/2s now. Remember, we change those so they're easier to work with. It's 1/2 x to the negative 1/2, putting the square root of x in the denominator. Okay, now the derivative of y to the 1/2 is 1/2 y to the negative 1/2 dy dx. Also putting the y in the denominator, or we can leave it. Doesn't really matter. I actually prefer these as fractions. It's a little bit easier to work with. But this is equal to 1 over 2 y to the 1/2 dy dx. Okay, now we have to do our product rule. So we take the first times the derivative of the second, plus the second times the derivative of the first, and this is what we get. So we have, if you look over here, in the numerator, you'll have x to the 1/2 power dy. In the denominator, you'll have 2, then y to the negative 1/2 goes down. Here, x to the negative 1/2 goes down, so it's y to the 1/2 over 2x to the 1/2 power. All right, now my third term is y squared. So the derivative of y squared is just 2y dy dx. Now we have to put all of this together. So the first term was 1 plus the result from my product rule equals 2y dy dx. Now remember, the goal is to solve for dy dx, but we have all of these denominators. So what we're going to do is find a common denominator. So when I look at these guys, we don't care about the dx. We have 2y to the 1/2, 2x to the 1/2. So my common denominator is 2y to the 1/2, x to the 1/2. So my first one needs everybody. He needs 2y to the 1/2, x to the 1/2. He needs this in the numerator and the denominator. My second one needs the x to the 1/2. And the third one needs y to the 1/2. And the 2y needs everybody. He will need 2x to the 1/2, y to the 1/2. Numerator and denominator. All right, that's what this step right here is showing. So once we have that done, you know all of your denominators cancel. Everybody but the dx, he's still there because we need to solve for him. So when we go here, we get 2y to the 1/2, x to the 1/2. Well, x to the 1/2 times x to the 1/2 is x. Y to the 1/2 times y to the 1/2 is y. Okay, now you have 2 y to the 1/2 plus y to the first. So 2 times 2 is 4. 1/2 plus 1 is 3/2, x to the 1/2. Now we're ready to solve for dy dx. So we're going to put the dy dx's on the same side. So we're going to subtract this guy over. We're going to subtract him here. Okay, now we got them together. Factor out your dy dx and divide. And I'm actually okay here. You do not have to rationalize that denominator. That's fine. All right, I hope you did well. Good luck on your homework. Make sure you post questions if you have any.